Welcome to the 16th hole of the Adventure Golf Unit. The 16th hole we are going to start looking at surface area. And one of the first parts of surface area is the unfolding of a shape, or starting to visualize all of the different sides, or all the different faces, of a shape. So here we have a triangular prism with two triangular bases that would be parallel to each other and congruent. And if I think about this shape getting unfolded, this bottom here would be this part right here. This triangular base would be the triangle here on the back side. This triangular base would be this triangle on the front side. This would be this rectangle that folds up here, and then this rectangle would be this back piece here. I show you this because sometimes when measurements are given and a shape is kept in its solid format and not unfolded, it's kind of hard for us to see. But when we unfold it's a little easier. And when we're looking for surface area, I'm going to find the area of this, the area of this, the area of this, of each of these faces, and then I'm just going to simply go through and add them all together. And once I've added all those areas together, I have the surface area of the shape. Here's a net of a rectangular prism. Again, this would be the bottom that it's sitting on. This would be the top, the back side, the front side, the left end, and the right end. And just unfolding it allows me to see all of the different areas that I will be adding together. When you're creating a net of a cylinder, it's a little bit different than some of the other shapes because the circle is pretty obvious on the top, and on the bottom that would be a circular base for this. But if you look at the part that connects the two circles, it's actually a rectangle. And what you should notice is that the length of this rectangle is congruent to the length around the circle. So it's almost like we're putting a label on a soup can, and that label has to go all the way around the can, which means it has the same length as the circumference. If I'm looking for the area of this shape, I'm going to do pi times my radius, which would be half of 10 squared. Pi r squared would give me the area of this circle, and I actually have two of those, so I'm just going to double that, times 2. And then I need to add the area of this rectangle, and if you recall, this length right here is congruent to the circumference, which is pi times diameter times, that's this length, pi times diameter times height, times 18. So this gives me one circle, multiplied by 2 gives me the second circle, circumference gives me the length of the rectangle times the height. I can punch all of that in one run on my calculator. Pi times 5 squared times 2 plus pi times 10 times 18. The surface area of this shape would be 722.57, and that's a rounded number. And we're talking about area, or how many little squares it would take to cover this, and it would take 722.56 square inches. Again, I found the area of this shape, and that shape, and this shape, and added them all together. If I look at this triangular prism, my triangle here is a right triangle. It's a right scalene, base of 12, a height of 9. So 12 times 9 divided by 2. That's how I find the area of a triangle. That's this front triangle, and I have a parallel and congruent triangle in the back. So I'm going to do times 2, and that takes care of both of my triangles. And when I do that, 12 times 9 is 108 divided by 2. Each triangle would be 54. And then I'm going to add to this, but I did all that in one step here. This back side, 4 by 9, 4 times 9, which is 36. And then I'm going to do the bottom, which is 12 times 4, which is 48. And I'm going to do this rectangle that goes across the top here, which would be 15 times 4. which would be 60. Now, one triangle, two triangles, plus the end, plus the bottom, plus the top. Or if I look at it with the calculations actually done, piece by piece, I just add all these pieces together. I prefer to do it as one long equation, just because it saves me time going back and forth. But I certainly see value in finding the area of each individual face and then adding them together. 12 times 9 divided by 2 times 2 plus 4 times 9 plus 12 times 4 plus 15 times 4. The surface area of this shape, if I add all these numbers up, they would add up to 252, and that would be in centimeters squared. Rectangular prism. My top and my bottom are 16 by 5, which would be 80. 16 times 5, and I have two of them, a top and a bottom. My ends would be 4 times 5, which is 20. I have two of those. So 16 times 5 times 2 because I have 2. 4 times 5 times 2 because I have 2. And then my front and back would be 4 tall by 16. And I have two of those as well. 4 times 16 is 64. And I can simply add all these up. And when I do this, the commutative property actually becomes very valuable here. I'm going to do 80 and 20 is 100, 80 and 20 is another 100, so that's 200. This is 128, so my answer here would be 328. And it would be in square feet, because it's how many squares it would take to cover this. So I found the area of each face. I kept my calculations very organized, and then I found the sum of those areas. This is the same example we went through earlier. Again, just looking at pi times my radius, which would be 5. My diameter is given, my radius is half of that squared, and I have two of those circles, so times 2. Plus, I need to find the area of this rectangle, which that circumference gives me the width, pi times diameter times the height. And when I do that, pi times 5 squared times 2 plus 10 pi times 18 was 722.56. Sorry, 57 when it's actually rounded. Square inches. If you do this as individual faces, pi times 5 squared, 78.54, and I have two of those. And then pi times 10 times 18 is 565.49. And when I find the sum, 722.57 square inches. So if I find each individual face, I can do it like that, or if I do one long equation, I can do it like this. In this case, my triangle would be pi times my radius is 10 squared, and pi times 10 squared is 314.16. It's a rounded number. And I have two of those circles, one on each end. And if I start one long equation going across, pi times 10 squared times 2, because I have two circles, plus my rectangle here would be 45 times my circumference, which would be pi times diameter, or 20 pi. 45 times 20 pi is 2,800 27.43. That is also a rounded number. That will give me my surface area, or I can add these two numbers plus this number. Again, you can see I've kept them pretty well organized so that I can see exactly what I'm calculating or adding together. If I add together my three individual pieces down here, I come up with a sum of 3,455.75, and that would be in meters squared. If I punch this in all in one run, pi times 10 squared times 2, because there are two circles, plus 45 times 20 pi, I come up with exactly the same number, 3,455 and 75 hundredths meters squared. This is the last example. We're going to look at a pyramid, and a couple things I want to point out with the pyramid. You have a base that could be many different shapes. In this case, we have a square, and then the pyramid has a height, and then each side has what we call a slant height. When you are looking for surface area, you will not use this height. You will use that when finding volume, but not for surface area. For surface area, we must use the slant height, and the slant height and the overall height are two different lengths. So in this example, you can see the actual height of this pyramid is not even given, but the slant height is. In this case, I've got a square on the bottom, and then I've got four triangular faces that are congruent. So I'm going to find the area of my square, side length squared. 25 squared is 625. I'm going to show you both ways, finding each individual face and writing out one long equation. And then my triangles will be base times height divided by 2, 25 times 32 divided by 2 is 25 times 16, which equals 400. And I actually have 4 of those triangles. Up here, I can do 25 times 32 divided by 2, and then multiply that by 4 because I have 4 of the triangles. So this gives me the area of my square base plus the area of one triangle times 4 gives me my 5 faces. Down here I can see 400, 8, 12, 16, 16, 22, 25 is going to be my surface area. Or I can just punch it in one run, 25 squared plus 25 times 32 divided by 2 times 4, because there are 4 of those triangular faces, gives me the same 22, 25, and that would be in square feet. You're now ready to get online and print out the 16th hole scorecard.